Quadratic functions part 2. Here we're given a function f of x equals 2x squared minus 16x minus 7, and we have 3 parts to answer. The first part says determine without graphing whether the function has a minimum value or maximum value. In order to do this, we need to first recognize that this function is given in general form, which is f of x equals ax squared plus bx plus c. Next, we need to identify the value for a. So in this case, a is 2. Since a is greater than 0, our parabola is going to open up. If we have a parabola that opens up, that means our vertex is going to be the minimum point. So, for part A, our function has a minimum value. Part B asks us to find the minimum or maximum value and determine where it occurs. We know that we're having a minimum value, and this value is found at the vertex, which is HK, where the minimum value is K, and it occurs at x equals H. To find the vertex, we're going to use the formula negative b over 2a. That will be our value for h, and then our value for k is f of negative b over 2a. And we're using this formula since our function is in general form. Right, so our value for b is the negative 16. So I have a negative of negative 16 divided by 2a, and the value for a is 2. So we have negative times negative is positive. I have 16 divided by 4, which is 4. So my value for h of the vertex is 4. Now I'm going to find f of 4. So I'll plug a 4 wherever I see an x in the original equation. So this is 2 times 4 squared minus 16 times 4 minus 7. And that equals 2 times 16 minus 64 minus 7. And 2 times 16 is 32. So we have 32 minus 64 minus 7, and that equals a negative 39. So our vertex is 4, negative 39. So my answer for part B is that I have a minimum value at k equals negative 39, and it occurs at x equals 4. Part C asks us to identify the function's domain and range. Here I just drew a quick sketch of what our parabola could look like. We know it opens up, and we have a vertex of 4, negative 39. Now the domain is the set of all x values. So the ends of our graph are going to keep on going out, and eventually hit all of the x values. So the domain is negative infinity to positive infinity. Now the range is the set of all y values. So as you can see, the range starts at a negative 39 and then goes up and up and up and goes on forever and ever because the tails of our graph continue on forever and ever. So the range is negative 39 to positive infinity. And remember, I have that bracket around the negative 39 and the parenthesis around the infinity sign. So those are our 2 solutions. Give the domain and range of the quadratic function whose graph is described. Maximum equals -8 at x equals 8. So knowing that I have a maximum point means that my parabola is going to open down. And then the maximum equals -8. Maximum values always occur at k. So I know that's a value for k. And then x equals 8. This is the value for h. So my vertex, hk, is 8, -8. Now I want to know the domain. The domain is the set of all x values, and like we said before, for all quadratic functions, the domain is always -infinity to +infinity. And that's because these tails will keep on going out and eventually hit all of the x values. So there'll be an x value for all x values in each ordered pair that the parabola has. Now the range is the set of all y values. So if we look at our parabola, the range starts at a -8 and then it goes down. So our range is -infinity, because you always put the smallest value first, to the -8. And remember that -8 is in brackets.